equilateral triangle from a line segment AB? Think about how you can do it. To construct the equilateral triangle, we have to find the third vertex other than A and B. For that, let's take a compass. We put the fixed point of compass on one of the points, say B. Now taking this line segment AB as the radius, we draw a circle with B as its center. Similarly, without changing the length of the compass, repeat the process by placing its fixed point on point A. Now we see that we have two circles with centers A and B, and both these circles intersect at these 2 points. So if we join points A and B to this point, we see that they are nothing but the radii of the circles. And since the radii of both the circles are equal to each other and also equal to the length of side AB, we get an equilateral triangle here. We will get an equilateral triangle even if we join points A and B to this point here. Wasn't it interesting? Such knowledge of geometry was known to people from ancient times. Around 300 BCE, the Greek mathematician Euclid combined all the knowledge of geometry known at that time in a set of 13 books called Elements. One interesting thing Euclid did was that he set out to prove that the geometrical relations known at that time follows logically from some simple things we know intuitively to be true. Euclid showed that the knowledge of geometry can be proven by just assuming some things to be true. These 5 true statements form the base of all modern geometry. He called these true statements or facts as postulates. You'd be wondering what the difference between axioms and postulates is. Well, in geometry, they are essentially interchangeable. The general meaning of postulate is a true statement. But in the case of Euclid, a postulate is a true statement, or rather a fact, that's applicable in geometry only. So in this lesson, let's take a look at the 5 important postulates that Euclid devised which helped him prove more theorems. Let's have a look at what the first postulate says. It states that a straight line may be drawn from any one point to any other point. To understand this, suppose we have 2 points A and B separated by a distance. Now, if we want to join them, we see that we can draw only one straight line that will connect the both of them. We can take the help of Euclid's axiom that states, given 2 distinct points, there is a unique line passing through them. So a line from A joining B is AB. Similarly, the line joining A from B is also AB. The second postulate states that a terminated line can be produced indefinitely. By terminated line, we understand that it's a line segment. This postulate means that if we have a line segment AB, we can extend both its ends endlessly. What about the next postulate? The third postulate says that a circle can be drawn with any center and any radius. This postulate is self-explanatory, but for our understanding, let's assume a line segment AB. Keep point A fixed and move point B around point A. We will see that it will make a circle, and the length of the line segment AB will be the radius of the circle. Likewise, we can draw a circle from any point and with any radius. The fourth postulate says that all right angles are equal to one another. Look at the square and a rectangle. We see that all the interior angles of the rectangle and the square are right angles. Therefore, an angle from a square will be equal to an angle from a rectangle. So, these are the Euclid's first 4 postulates that will help us having a better understanding of geometry.